Let's read the question, students. Enthalpy of neutralization of four acids A, B, C and D with NaOH are minus 10.5, minus 13.7, minus 5.9 and minus 12.7 kilocalorie per equivalent respectively. Out of A, B, C, D, the strongest acid is. Students, for this question, first of all, we need to know that for stronger acid, the negative value of enthalpy of neutralization will be more. That means more energy is released for stronger acid. So we can easily arrange the given acids in their correct order of acidic strength. So order of acidic strength is strongest is number B, then we have number D, then it is A, and the least acidic will be number C. That means the strongest acid among the following is B. So the correct answer is option number 4. Moving to the next question, students, which is 57. Let's read the question, students. Extensive property among the following is. The options are volume, temperature, pressure and density. Students, extensive properties are mass dependent. Among the following, volume is an extensive property. On the other hand, temperature, pressure and density are intensive properties. That means the correct answer for this question is option number 1. Moving to the next question, students, which is 58. The equilibrium constant for the reaction NH3 gives half N2 plus 3/2 H2 will be. Student, for this question, first of all, we need to know that if the equilibrium constant of a reaction is K, then on reversing the reaction, that is 2NH3 gives N2 plus 3H2, the equilibrium constant becomes reciprocal. And on multiplying the entire equation by a number, in this case the number is half, so the equation becomes NH3 1/2 N2 3/2 H2. The number becomes the power of equilibrium constant. That means the value of equilibrium constant is 1 upon under root K. So we can say the correct answer is option number 2. Moving to the next question, students, which is 59. Let's read the question. What is the pH of the resulting solution when 100 ml 0.1 molar CH3COOH is mixed with 50 ml of 0.1 molar NaOH solution? Here the value of pKa of acetic acid, that is CH3COOH, is given, which is 4.74. Students, this is the case of acidic buffer, and for acidic buffer the value or the formula to calculate pH is pH is equals to pKa plus log of salt upon acid. Now we need to calculate the concentration of salt and acid. For that, the equation used is CH3COOH, which is an acid. When reacts with base, it gives salt, that is CH3COO minus Na plus water. Now let's write the initial number of moles of acetic acid and NaOH, and then we'll be able to find out the concentration of salt and acid at equilibrium. Here acetic acid is given 100 ml, 0.1 molar. That means 10 millimoles of acetic acid reacts with 50 ml of 0.1 molar NaOH. That means 5 millimoles. This is at T is equals to 0. That means here the concentration of salt and water is 0. Now at equilibrium, 5 millimoles of NaOH reacts with 5 millimoles of acetic acid, and 5 millimoles of acetic acid will be left, 0 moles of NaOH will be left, and 5 millimoles of salt will be formed. Now student, we can put the values of the concentration of salt and acid in the given equation. So pH is equals to pK, the value of pK is 4.74 given in the question, plus log concentration of salt upon concentration of acid. Student, we can calculate the concentration of salt by dividing number of moles by volume. Number of moles is 5 millimoles, upon volume will be 150 ml, since 100 ml of acetic acid is mixed with 50 ml of NaOH. On the other hand, concentration of acid will be same, that means 5 millimoles dissolved in 150 ml of solution. So that means the concentration of salt upon concentration of acid is equals to 1, and as we all know, log 1 is equals to 0. That means the value of pH is equals to 4.74. So the correct answer for this question is option number 1. Moving to the next question, students. Let's read the question, students. Oxidation state of nitrogen in HCN, HN3 and NO respectively are. Student, I am writing the oxidation state. First we have taken HCN. Here the oxidation state of nitrogen will be -3. Next we have HN3. Here the oxidation state of N3 is -1. So the oxidation state of nitrogen will be -1/3. Next we have NO. So the oxidation state of nitrogen will be +2. That means the correct answer is option number 3. The oxidation state of nitrogen in HCN is -3. The oxidation state of nitrogen in HN3 is -1/3, and the oxidation state of nitrogen in NO is +2. That means the correct answer is option number 3.